Today is last lesson of Unit 2. And Unit 2 contains a few more derivative rules. We're going to find the derivative of cotan, tangent, cosecant, and secant to add that with the other ones that we already know. So just thinking, what have we learned so far in Unit 2? We've learned the power rule. We've learned the rule of the derivative of a constant. We've learned cosine, sine, natural log, e. We're picking up cotan, tan, secant, cosecant. We know the product rule. We know the quotient rule. So there's a lot of things to memorize in this unit that you'll want to know as you head into the Unit 2 test. But let's get on with the lesson today here. So it just says recall the derivatives of sine and cosine. Derivative of sine gave us cosine. Derivative of cosine gives us negative sine. And as you can see in the next blocks, you pick up derivative of tangent is secant squared x. Derivative of cotangent is negative cosecant squared. Secant is secant times tangent x, and cosecant of x is negative cosecant cotangent. One little hint I want to make sure that you're picking up is that if our derivative, let's get a highlighter here, if our derivative starts with a C, you'll notice that the derivatives all start with negative. So if I'm taking the derivative of cosine, cotangent, or cosecant, I know their derivative is going to start with a negative. That's the easiest way to remember them, and a lot of people don't get them mixed up then once they realize that. There is a proof. Let's walk through the derivative of tangent to show you how that turns out to be secant squared. It's not too bad of proof. So let's get a pen started here. If I want to take the derivative of tangent, I could say that I'm going to take the derivative of sine x over cosine of x, right? Those trig identities just come in so handy. All right, now I see a quotient. So let's use quotient rule. Derivative of sine gives me cosine times the bottom. I got to say it because that's the way I think it in my head when I'm doing it. Derivative of the top times the bottom, or f prime g minus g prime f. Derivative of the bottom gives me negative sine x, because it was derivative of cosine, multiplied by the top, which is sine x. All divided by cosine squared x. With cosine squared, I'm sure you're aware that you can write it either way. If I'm going to show squaring, then I better get an extra set of parentheses so that people don't think I'm squaring my x, but that I want the whole thing squared. I would say most of us write it that way, with the squaring sitting between the two functions. You can't enter it on your TI-84 in that manner. You would have to enter it like that, okay? Now let's simplify. That gives us a cosine squared minus minus creates plus sine squared x, all divided by cosine squared x. And heavens, I hope no one is thinking, oh man, that cancels and I'm left with sine squared. No, that doesn't cancel. Because of the plus sign in between there, we can't just simply cancel off one portion of our fraction. So that's a no-no. Let's back up then. What can we do? Well, Zabel did a great job of teaching you the identities, and I hope many of you, as you read that, sine squared plus cosine squared equals, what does it equal? It equals 1. And we get 1 over cosine squared of x. And we recognize that as cosecant. I'm sorry, it's not cosecant, because there's never two cos in a pair, right? Cosine and cosecant do not go together. It's secant squared x. So the derivative of tangent x indeed is secant squared x. Kind of a nice little proof. All right, find the derivative of each. I like this one. Y prime equals derivative of x, 1. Derivative of tangent, well, it starts with a t, so it's not a negative. It'll be secant squared x. The negative just comes down, and I get 1 minus secant squared. Yeah, there we go. Next one. Ooh, y equals x secant x. So if I want to take the derivative, I hope as you read it, you heard yourself say x times secant x. That means this is a product rule. Let's use our product rule. Derivative of the first times the second plus derivative of the second times the first. If you're an f prime g plus g prime f, awesome. If you're a u prime b plus b prime u, any of those work. So derivative of the first is 1 times secant x added with derivative of the second. Derivative of secant is secant x tangent x. Look at your table. And then it'll all be multiplied by x because that was the first. That's g prime f. What could we do? Oh, I see a secant x that's just begging to be GCF'd out front. So I get 1 plus tangent of x times x. I'm going to throw that other x up front. Then I don't have to use quite as many parentheses. That looks good to me. Next, we flip to the back. Pythagorean identities do come into play, and they are helpful. We just saw the use of sine squared x plus cosine squared x equals 1. What other two are there? There's 1 plus tangent squared x equals secant squared x. Also true, secant squared x minus 1 equals tangent squared x. And then 1 plus cotangent squared x equals cosecant squared x. Likewise, we could say cosecant squared x minus 1 equals cotangent squared. So some alternates ones there. I don't think I'm going to have you do this. This would be kind of nice, but I'm not going to do it on the video. We may do it in class. 1 minus cosine x over sine x is equivalent to saying cosecant x minus cotan. Last year in pre-calc, you would have shown, you would have followed the logic down through one side and showed that it was, that's so easy to do, isn't it? Do you see it? 1 over sine x. I just can't help myself. Cosine x over sine x. Split up those common denominators. And this is 1 over sine is a cosecant x. Cosine over sine is a cotangent x. And I just proved what we were asked to prove. Those are fun. All right. What this activity was supposed to have you do is show that the derivative of the left side turns out to be equal to the derivative of the right side. And we could have two people play along and do each side, and we would get the same answers. If you want to try it on your own, try it. Do the left side derivative. Do the right side derivative. Should turn out to be the same. The homework for today is a worksheet covering tangent, cotangent, secant, cosecant. Have fun with that. Oopsie.